Okay guys, so let's discuss the JEE main pattern exercises for the very chapter vector algebra. The first question says that if A, B, C, D, E, F is a regular hexagon, then AD plus EB plus FC vector is equal to what? Obviously this is a vector, this is a vector, this is a vector, so sum of three vectors is again a vector. Let's find out which is that vector, which is the resultant vector of the addition of these three vectors. Clear? A, B, C, D, E, F is a regular hexagon, so let's see. If you have a regular hexagon with you, I'm naming it as A, B, C, D, E and F. Now you know that AD, or if I'm saying this is O, then OD is equal to OA. It's like the midpoint. OE is equal to OB and OC is equal to OF. So first thing is that let's just interpret what are the vectors about which the question is speaking. AD vector, EB vector, FC vector. Okay, so AD vector is this vector from A to D. EB vector is this vector from E to B and FC vector is this vector from F to C. I am saying suppose AB vector is A vector and BC vector is B vector. If this is the case, you know that length of BC segment is same as length of AO segment. Direction if I keep to be the same, they are parallel to each other. You can see this. This is also going to be B vector. And exactly in a similar manner, OC vector will be A vector. If OC vector is A vector and OC is equal to OF, I can say that FC vector is twice of OC vector, but OC vector is A vector, so FC vector is twice of A vector. Similarly, if AO vector is B vector and AD, you know AD is equal to twice of AO, the direction is also the same. AD vector, AO vector direction is the same. Therefore, AD vector is equals to twice of AO vector, right? And AO vector is B vector. So, FC vector we have interpreted. AD vector we have interpreted. What is left is EB vector. EB vector. Let's look at this triangle OAB. In triangle OAB, you know this, that AB plus BO AB plus BO is equal to AO. Right? AB vector is A vector, BO vector I don't know, and AO vector is B vector. So clearly BO vector is B vector minus A vector, or B vector plus negative of A vector I can say. After this, if BO vector has been decoded, I know BO vector is actually equal to OE vector. Right, and twice of BO vector is going to give me BE vector. So BE vector is equal to twice of BO vector, right? BO vector is B vector minus A vector. Well, I don't want BE vector, I actually want EB vector. I know EB vector will be negative of the BE vector. That's how we basically decode each and every vector written in the expression. I have FC vector, AD vector and EB vector. So when I add AD vector plus EB vector plus FC vector, I actually get twice of B vector minus twice of B vector plus twice of A vector plus FC vector is twice of A vector. This gives you null vector, right? A vector plus its negative is going to give you the null vector. Null vector plus anything is that thing only. Twice of A vector plus twice of A vector is 4 times A vector. But A vector is nothing but AB vector. So the answer is 4 times AB vector. And that is your option number D. This is how you interpret this question, pretty easy, based upon algebra of vectors. Let us talk about now the next question. The next question says that if the position vector of a point A is A vector plus twice of B vector, and A vector divides AB in the ratio 2:3, then the position vector of B is what? So, there is a point A whose position vector is A vector plus twice of B vector, and there is a segment AB. There is some point C which has position vector as A vector, which is dividing the segment AB in the ratio 2:3. What is the position vector of B point? Suppose the position vector of B is C vector. Suppose, that means I need to interpret what is C vector. Now, I know by section formula, direct interpretation of section formula, A vector, the very vector which divides line segment AB in the ratio 2:3. The position vector is A vector. This is equal to twice of C vector plus thrice of A vector plus twice of B vector whole upon 2 plus 3. Twice of C vector plus thrice of A vector plus twice of B vector whole upon 2 plus 3. That is what is the section formula. So from here you get, this is 5. So 5 times A vector is equal to twice of C vector plus thrice of A vector plus 6 times B vector. So now 5 times A vector minus 3 times A vector, this gives you twice of A vector. Twice of A vector is twice of C vector plus 6 times B vector. So this gives you twice of A vector minus 6 times B vector is equal to twice of C vector. I can definitely take out 2 common. I am going to get A vector minus thrice of B vector is C vector. So C vector is the position vector of point B. So position vector of point B is A vector minus thrice of B vector. Let's see, A vector minus thrice of B vector, option number C is the correct option. Now, pretty much easy question just based upon section formula. Moving on to the next question, I have question number 3. This is a vector given to you which is rotated through an angle theta and doubled in magnitude. The moment it is doubled in magnitude, it becomes equal to actually this particular vector. Okay? This vector is rotated through an angle theta and doubled in magnitude, then it becomes this particular vector. That means it is becoming equal to this vector. Then the value of x is what? So, the very vector, when it is doubled in magnitude, the magnitude comes out to be equal to the magnitude of this vector. That means twice of magnitude of I cap plus x j cap plus 3k cap is equal to the magnitude of 4 I cap plus 4x minus 2 j cap plus 2 k cap. So when the magnitude of this vector is doubled, it becomes equal to the magnitude of this vector. Now, what is this? This is under root of 1 square plus x square plus 3 square. 3 square is 9, 9 plus 1, 10. You get 10 plus x square equals under root 4 square plus 2 square, 16 plus 4 gives you 20 plus 4x minus 2 whole square. Obviously, the next step is going to be squaring both sides. I am going to get 4 times 10 plus x square is equal to 20 plus 4x whole square. That means 16x square plus 4 minus 16x. So what is it that you have? You have 40 plus x square equals 20 plus 16x square plus 4 minus 16x. Now, 16x square, this is not x square, this is 4x square, right? This is 40 plus 4x square. So 16x square minus 4x square gives you 12x square. 20 plus 4 is 24, right? And 40 minus 24 is 16. So this gives you minus 16. See, this is 24 minus 40. 40 minus 24 is 16. So this gives you minus 16. And here you have minus 16x equals 0. This eventually gives you what? 3x square minus 4x minus 4 equals 0, because you can see everything is divisible by 4. I can take out 4 common. This gives you 3x square minus 6x plus 2x minus 4 equals 0. 3x, x minus 2 plus 2, x minus 2 is 0. You get x minus 2 and 3x plus 2 as factors. X comes out to be equal to 2 and minus 2 by 3. For these values of x, when I plug it in here, I get the magnitude of this particular vector. When it is doubled, it becomes equal to the magnitude of this vector. So the values of x are coming out to be 2 and minus 2 by 3. Let's see. 2 and minus 2 by 3. Fine. Now, over here, this rotation thing was just given for confusion. Actual thing could have been just brought by the very fact that the magnitude when doubled becomes equal to the magnitude of this new vector. If A, B, C are the pth, qth and rth terms of a GP, then the angle between the vector this and this is what? So over here, concept of GP is being used. If small a is the pth term of a GP, small b is the qth term of the GP and small c is the rth term of the same GP, I first need to assume two things. Let capital A be the first term of the GP and capital R be the common ratio of the same GP. After this, if small a is the pth term of this GP, small a will be a r to the power p minus 1. If small b is the qth term, it will be a r to the power q minus 1, and small c is the rth term, it will be a capital R to the power small r minus 1. Carefully observe the components of both the vectors log a, log b, log c, q minus r minus p, p minus q. Do one thing. Understand what happens when you do this. A when you raise to the power q minus r, b when you raise to the power r minus p, and c raised to the power p minus q. What is this? What is this? This is equal to a is what? This. So this will be a r to the power p minus 1 raised to the power q minus r. Then a r to the power q minus 1 raised to the power r minus p and a r to the power r minus 1 raised to the power p minus q. When you open this up, you get a to the power q minus r into a to the power r minus p into a to the power p minus q. That gives you a to the power q minus r plus r minus p plus p minus q, which gives you a to the power 0. Similarly, you get r to the power pq minus pr minus q plus r plus qr minus qp minus r plus p plus rp minus qr minus p plus q. Everything will be cancelled. You will get r to the power 0, which is 1. Now, obviously, the question itself is talking about the very inclusion of log. So, when I take log both sides, I get log of something into something into something, which is log of a to the power q minus r plus log of b to the power r minus p plus log of c to the power p minus q is equal to log 1, which is 0. This gives you q minus r log a plus r minus p log b plus p minus q log c is 0. What is this? Isn't this the dot product of log A I cap plus log B j cap plus log C k cap. This vector's dot product with q minus r I cap plus r minus p j cap plus p minus q k cap. It is the dot product of these two vectors which is coming out to be 0, but this vector is given in the question as u vector, and this next vector that you can see over here is given in the question as v vector. So basically you have u dot v is coming out to be 0. This implies u and v are perpendicular. The angle between them is nothing but 90 degrees. So pretty easy question, just the inclusion of log was necessary and you have your answer. The very way of finding the angle between these two vectors was an indirect manner, which was to show that the dot product is 0. Clear? Let's move on to the next question. Okay. So the next I have, if A vector is this, B vector is this, and R cross A is B cross A, R cross B is A cross B, then a unit vector in the direction of R vector is which vector? Okay, so A vector, B vector is given to me, and R cross A equals B cross A, and R cross B equals A cross B. This is given. So let's understand this. It's given R cross A equals B cross A. I know B cross A is minus of A cross B. If B cross A is minus of A cross B and A cross B is R cross B, I can write this as minus of R cross B. So now I can say R cross A plus R cross B is equal to 0 vector. Clear? I know that cross product is distributive over addition, so I can write this as R vector cross A vector plus B vector is 0 vector. What is A vector plus B vector? Okay, so before that, first of all recall what is the meaning of cross product of two vectors coming out to be null vector. It just means that R vector is parallel to A vector plus B vector. If these two are parallel, that means one has to be scalar multiple of the other. This implies R vector is lambda times A vector plus B vector. R vector will be lambda times A vector plus B vector for some lambda. Now, if R vector is lambda times A vector plus B vector, A vector is I cap plus j cap and B vector is 2j cap minus k cap. Let's add. 1 plus 0 gives you 1, 1 I cap. 1 plus 2 gives you 3j cap, so 1 I cap plus 3j cap, 0 minus 1 minus k cap, so 1 I cap plus 3j cap minus k cap. Right? If this is R vector, what is the unit vector in the direction of R vector? So it's a pretty direct concept. Unit vector in the direction of A vector is A cap. So unit vector in the direction of R vector is R cap, which is what? R vector upon magnitude of R vector. R vector is lambda times I cap plus 3j cap minus k cap whole upon magnitude of R vector. Magnitude of this vector is what? You can take out lambda, you are left with under root of 1 square plus 3 square plus 1 square, which is 11. So you get lambda root 11. And you have 1 by root 11 I cap plus 3 by root 11 j cap plus minus 1 by root 11 k cap. This is the unit vector in the direction of R vector. So let's see, you have I cap plus 3j cap minus k cap by root 11. This is that vector which is the unit vector in the direction of R vector, where R vector is a vector such that R cross A is equal to B cross A and R cross B equals A cross B, where A and B are given to you. Moving on to the next question, what is it that we have next is, now Question number 6. Let us define the length of a vector ai cap plus bj cap plus ck cap as mod a plus mod b plus mod c. Okay. So the question itself is defining the magnitude of a vector in some alternative fashion. It is mod a plus mod b plus mod c. Typically, I know that this is not the way in which length of a vector is defined. It is saying that this definition coincides with the usual definition of length of a vector if and only if. So suppose that both these definitions are coinciding. So if both definitions coincide, then magnitude of this vector ai cap plus bj cap plus ck cap from the first definition is mod a plus mod b plus mod c. That's given in the question. And this is coinciding with the usual definition of magnitude of this vector, which is nothing but positive square root of a square plus b square plus c square. Clear? When you square both sides, what you get is a square plus b square plus c square equals mod a plus mod b plus mod c whole square, which is mod a whole square. Mod a whole square is same as a square, plus mod b whole square, which is same as b square, plus mod c whole square, which is same as c square, plus twice of mod a mod b plus mod b mod c plus mod c mod a. You can very clearly see this is getting cancelled. You have mod a mod b. Now what is mod a into mod b? It is mod of a into b plus mod of b into c plus mod of c into a. Whole into 2 is 0. That means this is 0. Now this is non-negative, this is non-negative, this is non-negative, right? You know mod is non-negative. Sum of 3 non-negative terms is 0. That means each of the term is 0. This implies mod of AB is 0 and mod of BC is 0 and mod of CA is 0. When mod of something is 0, that means that thing has to be 0, because mod x is 0 if and only if x is 0. So this implies AB is 0, BC is 0, AC is 0. So this is 0 and this is 0 and this is 0. Suppose A into B, B into C, C into A, product of any two of these is 0. In that case, I say that both these definitions of computing the magnitude coincide with each other. So the answer is if any two of A, B and C are 0. Any two of A, B and C is 0. Clear? So basically the pair of AB, BC, CA should come out to be equal to 0. In that case, you say that both these definitions are going to coincide to give you magnitude. Whether you compute magnitude from here or you compute magnitude from this definition, it will be the same. So you can even save this as a property rather than a question, that this changed definition of magnitude is valid under which situation. Moving to the next question, I have A vector is this, B vector is this, and C vector is given to be this. A vector coplanar to A and B, step by step. First, I want coplanar to A and B. I am saying let R vector be coplanar to A and B. If R vector is coplanar to A and B, this implies R vector is A vector plus lambda times B vector. That's the meaning of coplanarity. Now A vector is I cap plus 2j cap plus k cap plus lambda times B vector is I cap minus j cap plus k cap. Now 1 plus lambda I cap, 2 minus 1, or I should say 2 minus lambda j cap, 1 plus lambda k cap. right? It is 1 plus lambda, 2 minus lambda, 1 plus lambda. This is my R vector. Now another feature is that it has a projection along C vector of magnitude 1 by 3. Projection, this is 1 by root 3, yes. So projection of R vector along C vector is given by what? It is given by R dot C upon magnitude of C. But this is given as 1 by root 3, it's positive, so I'm going to take the absolute value. If this is my very projection and this is given to be 1 by root 3, let's evaluate this particular expression. R dot C is what? C is given to be I cap plus j cap minus k cap. So I have this vector R vector dot product with this vector. So 1 plus lambda into 1, it is 1 plus lambda, plus 2 minus lambda into 1, so plus 2 minus lambda, plus 1 plus lambda into minus 1, so minus 1 plus lambda. Evaluate, this is 1 plus lambda plus 2 minus lambda minus 1 minus lambda. So this is 2 plus 1, 3, 3 minus 1 is 2, 2 minus lambda. Then mod of R dot C upon mod C is given to be 1 by root 3. What is magnitude of C vector? Under root of 1 square plus 1 square plus 1 square. So under root 3. So magnitude of R dot C is magnitude of this, which is magnitude of this, which is magnitude of this. So you get magnitude of 2 minus lambda upon root 3 is 1 by root 3. This means magnitude of 2 minus lambda is 1, or I can say 2 minus lambda is plus minus 1, or I can say 2 plus minus 1 is lambda, therefore lambda is 1 and, or I should say 2 minus 1 is 1, 2 plus 1 is 3, 1 and 3. Lambda is 1 and 3. For lambda equals 1, what is the very value of R vector that you get? R vector becomes 2I cap, lambda equals 1, 2 minus 1 is 1, 1 j cap, this is 1, so 2k cap. This is R vector, or one more very alternative for R vector is 1 plus 3 when lambda is 3, this is 4I cap, 2 minus 3, so it is minus 1, minus j cap, and 1 plus 3, which is 4k cap. I have 4I cap minus j cap plus 4k cap. This will be the R vector, which is coplanar to A and B, and it has projection along C vector of magnitude 1 by root 3. Clear? So the magnitude is 1 by root 3, so that's how you get the very answer. Now moving on to the next one, here only the coplanarity concept and the very fact that what is the projection of a vector along another vector is used. Next I have question number 8, take a look at it. It's talking about 3 vectors which are non-coplanar. Talking about 3 vectors which are non-coplanar. Then what is this? Now see, u vector plus v vector minus w vector is one vector. Dot product with cross product of 2 vectors. This is talking about scalar triple product of 3 vectors. Scalar triple product is equal to what is the question asking? So scalar triple product of u vector plus v vector minus w vector with u minus v with v minus w. This scalar triple product is what is this asking. Now interpret this as A vector, this as B vector, and this as C vector. Then A vector can be written as 1 times u vector plus 1 times v vector plus minus 1 times w vector. B vector can be written as 1 times u vector plus minus 1 times v vector plus 0 times w vector. And similarly, C vector can be written as 0 times U vector plus 1 times V vector plus minus 1 times W vector. Clear? Therefore, if this is A, this is B, this is C, and I know these are the coefficients, therefore scalar triple product of ABC will be what? Scalar triple product of A vector, B vector, C vector is equal to determinant of 1, 1, minus 1, 1, minus 1, 0, 0, 1, minus 1 times the scalar triple product of U vector, V vector, W vector. This property, if you don't know, you are going to be at loss, because this is going to help us get the answer very easily. This particular determinant comes out to be 1, 1 into scalar triple product of U, V, W. This is U dot V cross W. So this capital A vector dot capital B vector cross capital C vector is actually coming out to be U dot V cross W, U dot, this is U dot V cross W. So just understand this property, that whenever you have three vectors which can be written like this, x1, y1, z1, x2, y2, z2, x3, y3, z3 are the respective coefficients, then this scalar triple product is given by this. Determinant of all the coefficients into the scalar triple product of the three vectors corresponding to which they have been expressed. Now moving on to the next one, I have if A cross B cross C is equal to A cross B cross C. Okay. Okay, so this is talking about the vector triple product, right? A cross B cross C is A cross B cross C. So first of all, A cross B cross C is A cross B cross C. See, on the right hand side, the vector outside the bracket is on the leftmost side. So this is going to be A dot C times B minus A dot B times C. But over here that's not the case. The vector outside the bracket is not on the leftmost side. This will be equal to, what is this thing equal to? This is minus of, so I'm going to take it on the left hand side, this cross A cross B. Now the moment it is on the left hand side, now I can apply the same very formula. It is minus of C dot B times A minus C dot A times B. So you have minus of C dot B times A plus C dot A is same as A dot C. So this will be A dot C times B equals A dot C times B minus A dot B times C. I'm just solving this first expression which was given in the question. Now obviously you can see this and this are same. So they are going to give you the null vector. You are left with C dot B times A equals A dot B times C. The question further says A, B, C are three vectors. A dot B is non-zero, B dot C is non-zero, then A and C are what? So if this is non-zero, this is non-zero, I can say A vector is A dot B upon B dot C times C vector. This is a non-zero expression. I can say this is lambda, which is not equal to 0. That means one vector is scalar multiple of the other. Clearly it means that both vectors are parallel. Answer is that no, they are not perpendicular, they are parallel vectors. So just this first expression and the concept of vector triple product helped me to land till here. After that it was already given that C dot B or B dot C is non-zero. I can easily take it in the denominator. I get a lambda non-zero such that A vector is lambda times C vector, and therefore both are parallel. Moving on to the next one, I have the question that A vector is this, B vector is this. If C is a vector such that A dot C is mod C, Read it further. Mod of C minus A is 2 root 2 and the angle between A cross B and C is 30 degrees, then what is this? Okay. So step by step. A dot C is mod C and mod of C minus A is 2 root 2. Okay. So if mod of C minus A is 2 root 2, then mod of C minus A whole square is 2 root 2 whole square, which is 8. This gives you mod C square plus mod A square minus 2 times A dot C. A dot C is given as mod C. Mod of A vector is what? A vector is 2i cap plus j cap minus 2k cap. What is the mod of A? Under root of 9, which is under root of 9 is your what? Mod of A, that is 3 is mod A. So mod A square is 9. So this is 9 plus mod C vector whole square. This is 8. 9 minus 8 is 1. You get mod C square plus 1 minus 2 mod C, which is nothing but mod C minus 1 whole square equals 0. This gives you mod C is 1. Once you get mod C equals 1, you are also given that the angle between A cross B and C is 30. If the angle is given, I can very easily talk about the magnitude of this. What is the magnitude of A cross B cross C? This is magnitude of A cross B into magnitude of C into sine of the angle between A cross B and C, which is given as 30 degrees. Now, what is magnitude of A cross B? For that, we have to compute A cross B. A cross B is I cap, j cap, k cap, 2, 1, minus 2, components of A vector, and 1, 1, 0, components of B vector. So this gives you I cap 0 plus 2 minus j cap 0 plus 2 plus k cap. This is 2 minus 1. So what is the magnitude of A cross B? It is 2i cap minus 2j cap plus k cap. So the magnitude is 4 plus 4, 8 plus 1, 9 under root 9, that is 3. So you get 3 into 1 because mod C is 1, sine 30 is 1 by 2. So this is 3 by 2. So it's been asked what is the magnitude. Magnitude is nothing but 3 by 2. Clear? That's how the concepts are intermingled in questions and one complete question is formed. So for that you need to be very thorough with each and every petty concept also to actually get the complete and correct answer of the question. That's it from my side. Thank you.